Okay, these are the notes for 8.3, number 3. So the last part of 8.3. We are going to find the sum of finite geometric series, where in the last video for 8.2, we found the sum of the arithmetic series. And this is finite, so there is a certain number of terms. Okay, so a geometric series, instead of adding to each term to get to the next term, which is what we do with arithmetic, we multiply. And the equation for finding the sum of the finite series is right here, where the sum will equal the first term times parentheses 1 minus the common ratio to the nth power, which is number of terms, over 1 minus that common ratio. Okay, so again, when you see it in sigma notation, that's like the number of terms up there, and the starting term is usually 1, and then the sequence is your geometric sequence, which is usually in the form of the first term times the ratio to the n minus 1 power. Okay, so if we look down here at number 1, that's exactly the form it's in. So here's n. This is A1, and that is R. It just uses I instead of N. Or I'm sorry, yeah, instead of N. So that's what we need to find the sum. We need the A1, which is 4. We need N, which is 10. And we need R, which is 3. And then we're plugging it into that sum equation. So I want the sum of the first 10 terms, because that's what that number is. And that will equal A1 times parentheses 1 minus R to the nth power over 1 minus R. And I just type all of that into my calculator. When you do that, however, you do need to make sure you put parentheses, like a little extra parentheses in there, like that, so that your calculator doesn't just divide by 1 and then try to subtract 3 or something like that. So if I plug all of that into my calculator, the sum of the first 10 terms is 118,096. Okay, so number 2, same thing. We're going to need our n, which is right there. So n is 8. A1 right there is negative 16. And then that is R, which is a 1/2. Okay, so I'm going to plug that into the formula where the sum of the first 8 terms is the first term times 1 minus the R to the nth power over 1 minus R. And you don't have to put those 1/2s in parentheses. I just kind of wrote them in parentheses, but the parentheses didn't need to be there. Again, though, when you put this in your calculator, make sure the parentheses are around at least the 1 minus half, and you can enter it in as 0.5, whatever, just to make sure that it keeps the numerator, everything on the numerator, being divided by everything in the denominator. And so your sum of the first 8 terms, once you punch that in your calculator, is 31.875. which is the same thing as saying 255 over 8. Both of those answers would have been correct. So now for number 3 and 4, it has some steps. It's not giving us the sigma notation, which sigma notation gives us all the pieces we need. This doesn't give us all the pieces we need without us actually figuring something out, which it's not hard. It's the first thing we see, but we find the first term that it does give us. Find the common ratio, which is what we have to just figure out. What is it multiplying by each time? And then finding the sum. Okay, so this wants the first 7 terms, so I know n is 7. I know the first term right here is 6, so A1 is going to be 6. And then what do I multiply 6 by to get to 24? I multiply by 4. 24 times 4, that's a times there, is 96. 96 times 4 is 384. So my R is 4. That was my common ratio. And I'm going to plug it in to my equation. So the sum of the first 7 terms is the first term times 1 minus r to the n power over 1 minus r. Plug all that in your calculator. Make sure to put parentheses where they need to be. And you should get 32,766. All right, so number 4. Now on number 4, I had a little bit of a typo or just mistake, we'll put it that way. When creating the problem, I multiplied the -3 times -15, or times 5 to get -15, but then it was like times 3. So this needs to be a -75, and that needs to be a -375. Okay, so we need to find our n, which is the first 11 terms. Our A1 is that first term right there. And then I'm multiplying by 5 each time to get to the next term. So my R is 5. And I'm going to plug it into the sum of the first 11 terms is the first term times 1 minus r to the n power over 1 minus r. Plug that in your calculator, and it's a really big number, -36,621,093. Okay, so those are the last set of notes for 8.3. The only thing left is the 8.4, which is geometric infinite sums. So, and then that is it for after 8.4. That is it for new material.